So welcome back, everyone. I would like to thank you, of course, for joining our second session of the day with Manuel. So we will be hearing from Manuel Kagelman, who joined Webasto, in 2010. Since then, he has gained an extensive experience in the field of e-mobility in the BD side, and since 2019, he has been responsible for product management for the batteries division. So he will be speaking on the battery and thermal management electrification solutions for off-highway equipment. So I would like to pass you over now to Manuel, who will be doing his presentation. So please take it away.
Thank you very much, Leon. So good morning from my side. Very happy to speak today on this interesting topic. And I will now try to share my screen with you to start my presentation. All right. So I'm not used to Zooms, so please excuse if not everything is working properly. All right. So I hope everybody can see the presentation. And I would like to speak today about how to maximize efficiency for electric construction vehicles with our battery and thermal management solutions. To start, a few words about Webasto. I guess most of you know us. We are more than 100 years old, one of the top 100 automotive suppliers, globally active. At approximately 50 locations and 14,000 employees. In normal times, we have approximately 4 billion euro sales turnover, and we are still family owned, which also leads to a solid equity ratio. And yeah, we are since 2015 active in the area of e-mobility, since then with our high voltage heater. And from that, we expanded our product portfolio continuously. So we still have the biggest share of our business in the roof business, so panorama roofs, convertible roofs, and also the heating and cooling business. There we currently transform from the fuel-operated heater business to the electrical heater ones, so according to the market development. And very important for us, the area of e-mobility, batteries and charging solutions, which we entered some years ago. And today I would like to speak a little bit more about this kind of solutions. To bring you in the right mood for e-mobility, I would like to show a short video, and I hope you can also hear the tone. So short question, Liam, I just got the message that you can still see the starting screen. Is this the case?
So yes, we did see the video, Manuel, but there was no sound. If you click on share screen again, there should be an option at the bottom that says share sound, computer sound as well.
Oh, okay, so my bad. As I said, I'm not so used to Zooms. Okay. So I will start.
With our future-proof battery systems, we're going to ensure the mobility. ensure the mobility of the future. Engineered to perform and last in our high-quality testing and production facilities. Whatever the future brings, we're going to be one step ahead, as it is embedded in our automotive DNA for more than 90 years. We create future-proof mobility for everybody, today and tomorrow.
Okay. Takes a little bit. No. Okay. Now back to the presentation. You just saw a little snapshot about our battery solutions, and I would like now to explain why we have decided to enter that exciting area. And I think you can hear daily news about the battery side of e-mobility. So a brief explanation about that. In our existing business, we know how to do products in OEM, processes, quality, and also the according volumes. We have broad experience when it comes to mechanical engineering and system integration, which we used for the housing and the construction of the battery. Thermal management is a key for batteries. I will speak a little bit later about that. And we use this know-how, which we have on the Webasto side, for the construction of the battery, for the cooling system of the battery, but also when it comes to the additional products which we offer in that area. We have our in-house testing and prototyping capabilities, which is very useful if you develop batteries. We have a global footprint, so we can produce on customer side, and we have E/E competence, which we can use for development, but also to produce electric and electrical components. And of course, very important, the battery know-how. We brought on board, so we hired the best people from the battery industry with decades of experience when it comes to develop batteries, and to bring all together makes it quite attractive as a battery supplier. What is the product portfolio? So on the one side, we offer individualized batteries for the bigger OEMs, which want to have a fully customized battery, could also be able to print, could be a complete pack. So we are very flexible also when it comes to the kind of cell, which is the heart of the battery. On the one side, and I would like to speak about this a little bit more, standardized battery systems for smaller customers, for those customers which want to try e-mobility, which can adapt the vehicle a little bit so that the product fits, and in regards to that, don't have any development costs or waiting times for the product. So e-mobility and off-highway, some lessons learned from other industries, what we've seen there and how we see it for the off-highway market. So what we learned in the last years is that electrification, or the success of electrification, is really a combination out of regulations, so CO2 emission reduction requirements, but also cost improvements. When we speak about cost improvements, of course, also subsidies are a massive lever. So in the car market, in the last month in Germany, the EVs took up to 20% of the new sales. So this could also only be possible in a combination out of these topics. We saw that the public tender business was moving towards electrification for the bus market very strong, but this now happens also in the construction market and will then be a decision criteria for public tenders. When we speak about reduction of emissions, this cannot only achieved by special kind of electric vehicles, battery electric vehicles. So this can also happen via hybrid solutions. This is always an entry point to increase efficiencies of existing vehicles. Can be the full electric. For sure will also be fuel cell. So it will not be only one technology. And maybe also the alternative fuels will be met in the future. What we see and what is interesting for the off-highway market is that the availability and the costs of the high voltage components will further optimize with the market development. Also thanks to the automotive industry where those parts can be used. And as biggest cost factor of a battery, the cell prices will be, the battery will be more and more attractive. So there are so many cell production sites planned in Europe that this will increase the competition and will be good for battery pack suppliers, but of course also for the manufacturers and then the user of these kind of vehicles. When we look on the technology development on electrification, we already see that we are moving from the low voltage area to the high voltage area. Of course, there's much in between. There are hybrid solutions also with high voltage components. But the trend goes, especially for the bigger machines, clearly towards the 400 or 800 volt. And on that battery technology, we see that the lithium ion now is the cell type of choice, and also there we will go towards the high voltage. Nevertheless, there are still some challenges when it comes to electrification, especially when we now look on construction machines. So the vehicle complexity is bigger than in other kind of vehicles. We don't only have a drivetrain for driving, but we also have hydraulic components for working. So this needs to be then considered in the complete electrical system. In this case, it's good if you have really a battery system, which is thermal management friendly and which can be easily integrated from the thermal management side, but of course also then from the electrical and communication side. Weight can be a topic, depends very much on the kind of construction machine. So weight is not bad in construction, but too much weight is also not appreciated. Then we have complex installation spaces. If we now look into existing construction machines where we make a change into electrical ones, so those ones who are not developed on the scratch, there it's more complicated to integrate battery systems, especially if you take typical ones in typical dimensions, like from the automotive areas, because this can be then too long. So it's good if the battery system is flexible and can be installed in different kind of ways, installation ways in the vehicle. What we also see is that some manufacturers are a little bit afraid of high voltage provisions and don't have the know-how. Of course, it's easier to take low voltage technology because there are less requirements and safety is not the topic like with high voltage. So people need to be trained, people need to be aware about how to work with high voltage. TCO is a good question because in the end everything comes to TCO. So I think there we are already at in a changing environment. When it comes to 800 volt components, it's still for some kind of components difficult to get them. Also the costs are not due to a lower volume which is sold in the market, it's more difficult. But looking on the 400 volt area, there it's getting more and more interesting. And if I remember right, in one of the last conferences, also off-highway, some manufacturers told us that after 3 or 4 years, the electric vehicle is already amortized and then is more attractive in terms of TCO. I already spoke about component availability. The higher the voltage, the more difficult. And if we look into the use case, this is also a criteria if it makes sense to electrify an electric machine or a construction machine. So if you have constant high base loads, whether for driving or for working, then it doesn't make so much sense. Still, in a battery can only be saved a limited amount of energy. So if you really need to have the continuous power all the time, then other kind of drivetrains might make more sense. If we look on the charging infrastructure and time, this is also a key criteria. If you think, for example, in a quarry, use a EV there, and if you don't have any infrastructure, it will be difficult. You need to have some kind of energy storage or whatever. Needs to be decided. But if you have the according infrastructure, if you can do overnight charging, then it's quite useful to go electric. And last but not least, the operating duration and time. If you have a machine which is only running seasonally, then maybe 24 hours, like to harvest or whatever, then it's not so useful. But if you really have a machine which is running all year at certain times, then it's quite a good thing to go electric. So at all, I would say the specific use case is determining if it makes sense to electrify a off-highway machine. If we speak about the kind of voltage, now it is a good time to try to go high voltage, especially if it's for the medium-sized or bigger machines. If you have a very small machine where you only need a limited capacity, you can also use the batteries you get from the forklift industry, because those are also in a attractive price area. But thinking about high voltage, the availability and choice of automotive battery systems and also the according charging solutions is getting better and better. So off-highway manufacturers can profit here from a price decrease, which is then also relevant if you compare high and low voltage. Also, if you want to achieve a higher battery capacity, there are limitations in using low voltage. So if you want to achieve, 40 kilowatt hours is already a border looking on the current which is then required. But thinking about machines with 100 or 150 or 200 or more, then 400 volt is the only choice. Also, you have less cable cross sections with high voltage. And if you want to increase the charging speed, the more the better. Of course, with 800 volt, you need according charging solutions, which are not as available as for 400. But if you really want to load the battery and the vehicle in a sufficient time, this will only work with high voltage. So having said that, how looks our solution, our product for construction machines? We have our standard battery pack. As you can see, it's quite compact in dimensions, with approximately 1 meter length. So it's not as long as usual automotive batteries. It works with 400 or 800 volt systems. So all components are developed for this high voltage. We can achieve up to 8 years or 8 years or 3,000 life cycles, which should be sufficient. When I think about the latest conferences I watched, and requirements from off-highway. And the requirement for cycles was between 1,500 and 3,000 cycles. And for that, we use a prismatic NMC cell, which we get from Samsung. So why is this product also suitable for off-highway machines? We can meet the platform approach that a lot of our customers follow. So no matter if you use one or if you have a smaller or a bigger machine, you can use 1, 2, or 10 of the battery packs, and by that scale the system up to the capacity requirement of the specific vehicle. 400 or 800 volt. As I said, we have a master BMS system, so our so-called VIB, vehicle interface box, which is the single interface to the ECU, means the packs don't need to be balanced by the vehicle. The cell inside the battery pack is a very robust PHEV cell, so also chosen for the long lifetime. The compact dimensions also, and together with the vertical integration possibility, so horizontal and vertical, make it quite easy, or offer different kind of possibilities to integrate them into a construction machine. Of course, it's very thermal management friendly, our system. This is one of our assets. DC charging as a must for most of the customers. We have a very robust housing out of aluminum extrusion profile, and we took very much attention on redundant safety measures, so that this is really considered, because some people are afraid when we talk about batteries, but there we took all the needed actions. Of course, we have ISO 26262 to put no risk into our battery. A part of that, as Webasto, we are globally active. As I has already mentioned, the product is off the shelf available, also in small batches. We support the customer over the complete life cycle. So from first questions, installations, R&D support, commissioning, and then also when it comes to topics in the serial phase of the vehicle, the end of life. So everything is considered, and we support the customer via this journey. We have the according thermal management solutions, which I will show now, to optimize the range and the lifetime, and also the charging times of the product. And very important also when it comes to the off-highway market, the product can be online monitored, so the customer can see the state of the battery, the health. Also this is considered. Speaking about the advantages of thermal management, I think most of the people know about it, but I would like to explain it again. So first of all, the battery lifetime can be prolonged up to 20% under certain conditions or certain simulations. Of course, this is very much specific, but too much heat is not good for the battery, as we know. So above 40 degrees, the battery is harmed in its lifetime. So if the battery is cooled, this is already considered. In the thermal management, we can reuse thermal energy, waste energy from the other components. We can extend the electrical range if the battery is not too cold. And we can, in the end, reduce the weight and the volume of the complete vehicle, because we reduce battery packs. So if we have the battery always under perfect conditions, we can reduce battery packs, because thermal management is one of the influencing factors for the range and for the capacity. So when it's very cold in winter times, it can happen that an electric vehicle can only meet up to 50% of the usual range. So you can see that if this is optimized, less batteries are needed, which is then attractive for the complete TCO of the vehicle. We speed up electrical charging times if the battery is already preconditioned. We can use it for every application. And in the end, this is what we want to do with e-mobility, protect the environment. So also here we have this two-pillar approach. We can deliver a standard product. It's called electrical battery thermal management. So in this case, only for the battery. Keep it under perfect conditions, but also a complete thermal management solution for the complete vehicle. So also for drivers, for passengers, reuse the heat, and all the other components which are needed to be kept under certain conditions, or which give heat which we can use. Here you see our EBTM. So we say it's plug and play because the battery and the EBTM have been developed together. So the communication is considered. The EBTM is controlled by our VIB, the master BMS system. So the vehicle don't need to take care. Of course, we know exactly which kind of conditioning the battery needs. So this is then also considered that we don't waste any energy for heating or cooling, which is not needed. We have a heat pump inside, which should be state of the art for a efficient thermal management. We can condition up to 6 battery packs, which means 210 kilowatt hour. At the moment, we have it with the usual refrigerants, but we also are planning to offer it with a CO2 version, 400 or 800 volt, like for the battery. And for the cold countries, we can offer an additional 5, 7, or 10 kilowatt electrical high voltage heater as an additional heat source. The EBTM and the battery pack are a complete system. So the electrical balancing of the system is also considered. And by that, we also save energy, which can then be used for working or driving. A little bit more facts, technical facts. You can see here that up to 6 battery packs can be connected. Communication is aligned to the battery, working conditions fit together, and also dimensions are quite similar, so that these products can be used in the same environment. But of course, this product can also be used with other batteries, if this is desired from our customer landscape. Okay, if we speak about an integrated thermal management, we say that this can achieve or increase a range optimization of 25% if we really do the passenger, the driver, and the battery conditioning, cool the electric motor and other electronics, use waste heat, then this can be 25%. If you calculate this, if you only need 3 instead of 4 battery packs, this is already a huge cost savement, so should be considered from the manufacturer. To show a reference case, we have a lot of projects ongoing, and I would like to show more. So I'm very sure in the next conferences we can show more kind of references and use cases. But here we have a first one. It's a 13-ton wheel loader, which was converted from Danfoss, which is very active in the area of e-mobility, into a full electric machine. We supplied the battery system, so 4 of our CB standard batteries and the VIB. Of course, the machine has 2 electric machines for driving and working hydraulics. and Danfoss decided to go 800 volt, and I'm sure due to good reasons. This confirms, I would say, what I've told you in the beginning about why to go high voltage. So nice use case. To end with my presentation, I would like to show again a short video about our production, so how we produce batteries, to show that it's real. And of course, also the customers are invited to see. I hope soon traveling will be more easier again. With that, I would like to end my presentation, and I hope this time it works better. So that's all. Thank you very much for staying with me, also if it was a little bit bumpy in the beginning. And now I'm looking forward for your questions. I will also be in the conference all day. So if you want, you can also send me a message all day and I will answer it later. But now back to Liam, I would say. Thank you very much.
You are very right. No, thank you very much, Manuel. It was a very good topic to speak upon, and we've actually had 10 questions, 10 very good questions. So of course we are running a bit over into break, so we will ask, I'd say, the top 3, top 4 that have been upvoted. But as Manuel said, Manuel did say he will be at the event today. So if you do have questions, please go speak to him through the virtual meets or the direct messaging. Also, if you go to the sponsor tab, you will notice that Webasto are at the top as our gold sponsor. So, of course, you know, please do go visit that booth, go ask questions, go see what sort of innovations they are bringing at the minute. But yes, so we will start with Andre Almeida, who asked a question with 15 upvotes. So a very important question, I believe. So what voltage levels do you see being used for smaller construction machines? 48 volts, 96 volts, etc.?
Yeah, at the moment, mostly a 48 volt. As I said in the beginning, those kind of batteries can be used from the forklift industry. So also big volumes, quite interesting in terms of costs, less 96. But also interesting, we also was in touch or have been in touch with a big manufacturer of forklifts. So I cannot say the name, but he said for the bigger forklifts, he already wants to go into 800 volt with our system. So this was one of the key criteria to talk with us about the product. Now, due to COVID, he postponed his plans, but this is already a huge jump from 48 to 800 volt.
Great, thank you. Yes, please let us know if that was answered well enough for you, Andre. Also, Andre Almeida, again with the 9 upvotes. What regulations go over construction machines, not forklifts, for electric safety? Basically, they're a bit lost on what regulation applies when choosing for low versus high voltage.
Yes, so we use the 26262 for functional safety. And also if you have, in terms of certification, if you think about DCE certification, then you have there also specific regulations when it comes to safety. So for example, one important regulation there is the 62619. Especially for lithium-ion batteries. In this norm, it's also explained how the propagation should be handled, so that a thermal runaway is avoided. And this is also something which we evaluate at the moment very deeply so that we can also offer this CE certification with our product.
Great, thank you very much. So yes, also, Jerome Younger asks, what is the dominant form factor of the lithium-ion cell for non-road mobile machinery? Is it cylindrical, pouch, or other?
Yeah, so all kind of cells have their specific advantages. So at the moment, the trend, or this is a general topic, so I would not say this is specific for on-road or for off-road. Of course, for some specific vehicles, you have a trend. But at the moment, still prismatic cells are used quite frequently. But we see that more and more a trend towards the cylindrical ones. Those are smaller, and therefore you are more flexible when it comes to develop battery packs and to develop certain kind of form factors. So speaking about the form factor of off-road machines, there we see that the more cubical ones are more sufficient. So as I mentioned also in the beginning, a long automotive battery will not always, a long and not as height battery will not always fit into a construction machine. So there, what we call a little bit the Lego approach is quite sufficient, because then with a smaller capacity, smaller size of the battery pack, you can implement it into the installation space of a construction machine, how it's suited. With one big product, it's more complicated. Liam, you're on mute.
I do apologise about that. I should know that. I work with Zoom a lot. But no, I think we can squeeze in another two quick questions. And apologies to everyone else who's asked a question. But as said, you can directly message Manuel or go to the sponsor exhibit booth, and the answers will be answered. The questions will be answered there. So we do have an anonymous one. Sorry, struggling with that. So is there a trend to 800-volt systems for heavy-duty applications?
I would say yes. As I showed in the reference case, this wheel loader, which was converted, goes to what, 800 volt. We see also that the component availability is getting better, like this inverter, high voltage heating, cooling, and so on. So I would say yes. For sure, this will also be influenced by the automotive area. So if you have the according charging solutions available, then it makes sense. If you only have a very expensive charger with cooled cable and so on, then it might not always make sense. So I would say it's a little bit depending also how the trend in the automotive area will continue. It will for sure take a little bit of time, but then it makes sense due to the efficiency and faster charging rates to go already towards the 800 volt.
Great. I'm not muted, am I? No. So I think we'll move on now to the final question for this session. Again, I do apologise to everyone who has asked and not been answered, but like I said, please do reach out. So what will be the dominant cell technology for non-road mobile applications in short term, LFP, NMC, or other?
Ooh, this is a crystal ball question. To be honest, if you would have raised that question 1 or 2 years ago, I would say, clearly NMC. Because there are more development cycles available, so the NMC technology is not as its end. Nevertheless, the LFP technology has squeezed out everything on the latest run. So I think in the future it will be clearly NMC, but still LFP is not to underestimate, and will join us for a certain while.
Fantastic. No, massive thank you there, Manuel, for obviously doing the presentation as well and joining us for the days today and tomorrow. So again, I'd just like to repeat, if you do have more questions for Manuel, and I know people didn't have the answers, please do directly contact him. But for that, a massive thank you again, Manuel.
Thank you very much for the time to talk here. I will answer all the questions during the day. Thank you for the interest, and yeah, maybe I will meet somebody of you somewhere in the world or virtually again. So thank you very much.
Let's hope after the pandemic anyway. But no, thank you, Manuel. Yeah, so of course, big thank you again to Manuel, but Webasto as a whole as well, being our gold sponsors for the event. Of course, their commitment and support for the event has been extraordinary. So a massive thank you to them as well. So we will be going on a short break now. The original break was for 30 minutes, but we've only had 2 sessions, so I think we can cut that down for a 15-minute break and still join back at 10:40 Central European time, where we will then hear from Tatiana Minav from Tampere University, talking about energy savings versus challenges in heavy-duty applications. Before we do go on this break as well, I just want to make another point of the sponsors tab. Please do go to the sponsors tab and see through the videos they've got. Some have a live demonstration, and of course there's going to be a lot of information there that could help your processes in the future. Also, we do have on the community tab a virtual meetup, which is happening now. We are actually working with quite a few of our sponsors within these virtual meetups, including Webasto. So please do go join them there for a virtual roundtable discussion for 15 minutes. But from me, that is all, and we will be back in about 15-16 minutes to hear from Tatiana. So enjoy your coffee break, please do go network and engage with everyone, and I look forward to seeing you then.